Okay, so with this one, we're saying Ladybug A begins walking a circular path in the direction of the disk rotation. Does the magnitude of the angular momentum of the disk alone, not the Ladybug's disk system, increase, decrease, or stay the same? This one is tricky and it's hard to think about, but what it really boils down to is our conservation of angular momentum. So just like linear momentum, angular momentum is conserved. So we can say that the angular momentum of our system is made up of the angular momentum of the ladybug and the angular momentum of the disk. And we're going to say that this is one system, and we're really looking at this total, so it's like the angular momentum of the system. We know that the angular momentum of the system is conserved because we don't have any outside forces acting on it. So what's weird about this is we are asking kind of about more individual pieces of our system. So instead of looking at the system of a whole, we're looking at the individual pieces of the system. So the ladybug begins walking in a circular path, which means that the ladybug, its angular speed is going to increase. It's going to start covering, if we kind of look at this overhead view, it's going to begin covering more radians each second because it'll be going along with the disk. So um, its angular velocity is increasing because it starts to cover more radians in a same amount of time because it's walking along with it. So because its angular velocity goes up, we know that angular momentum is I rotational inertia times the angular velocity. So for the ladybug, its angular momentum has increased. So the angular momentum of the ladybug has gone up, but we need to make sure that the angular momentum of our system stays constant. So if the angular momentum of our ladybug goes up, that means that the angular momentum of the disk has to decrease in order to keep our system constant. If you want another way of thinking about that, you can kind of look at this is going to be a bad drawing, my ladybug. That's not the worst, I guess. There's probably been worse ladybug pictures. So we have this ladybug. While this ladybug is walking, oh, that made it bad. It's applying a torque, right? It's applying a frictional force along this disk, which is technically slowing it down. So we have two ways of thinking about it. I prefer this kind of system approach, but you could also think about it piece by piece. If you treat the disk as its own piece, the ladybug is supplying a torque over some amount of time on the disk that is against its direction of motion, so it is decreasing its angular momentum. All right, so then we're going to move on to C in the next video.